Good day to our thesis advisor, Engineer Abigail Joy España, and to our technical advisor, Engineer Teodoro Nimuan. To the panelists, Professor Zacaria Jan Belmonte, Dr. Rexmel F. De Capia, Dr. Jun Raymond L. Mariano, Engineer Louis Canta, Engineer Rendel M. De Ligos, and lastly, Engineer Eugene Singson. I am Lloyd Kenneth B. Suba, the leader of Group 6, and I would like to greet you all a pleasant day. We will be presenting a proposed study entitled Design of the Customized Device with a Camera for Detection of Surface Crack, together with my groupmates Mr. Noordin M. Macalolot, Mr. Ren Cedric P. De La Rosa, and Mr. Vince B. Hilapo. I'm here to present to you the background of the study, general study, and specific objectives of this research. Background of the study. We were motivated to carry out this research because we learned the cracks are the most serious welding flaws according to the types of welding defects. In production, it is practically never authorized. It might appear on the surface, in the weld metal, or in area that has been exposed to the high temperatures. It also implies that based on visual examination, a product flow can be misconstrued as a defect product and vice versa. It is required to address the lack of clear and uniform quality requirements because human vision is not perfect. Double-checking the accuracy of the steel defect is also a good idea. We have decided to perform this research because we believe we can construct a steel double-checker device to empower inspectors in quickly identifying fractures in a way that allows them to demonstrate that what they say is correct by providing evidence. The eyes are primarily used when it comes to detecting cracks, as some inspectors don't have that kind of privilege. It is why we have invented this device to help. To the general objective of the study, we aim to design and develop a customized device with a camera for the detection of surface cracks on the weld plate, so that inspectors may be sure that the flaws they see in the materials are correct, and they have the proof to show their clients that the defective materials need to be fixed. To the specific objectives of the device, our first is to locate a hairline surface crack in the test specimen. Second, to save the image of the captured surface crack in the test material. Third, to record the time and date when the material is inspected. Fourth, to increase the credibility of the testing. Fifth, to identify the effectiveness of the camera device sensor in detecting surface crack in the test specimen. And lastly, to prove the accuracy of the device in test and detecting surface cracks in the test specimen. To the scope and delimitation, Gantt chart, and methodology, here Mr. Ren Cedric P. De La Rosa.
Thank you, Mr. Lloyd Suba, for presenting the background of the study, the general objective, the specific objective of our thesis. I am Ren De La Rosa, and I am here to present the scope and delimitation, the Gantt chart, and the conceptual framework 1 of our thesis. Scope and delimitation. The scope of our study is to detect surface crack on the weld plate. To save image, more than 1000, but it is upgradable depending on the SD card inserted on the device. To specify the date and time of inspection to have more credibility. To replace camera as long as it is a USB or AUX port, and to last the device until 4 to 6 hours. The delimitation of our study is that it is unable to detect subsurface and internal cracks. It is only limited in detecting surface cracks, not capable of detecting the other type of discontinuity, not capable of detecting the size and depth of cracks, and the device is applicable to any type of material, but the study will focus only on the detection of surface crack in weld plate. Next is the Gantt chart. In Gantt chart, we start making our thesis on the week 4 of February until the week 1 of April. Here are the tasks that we do in doing our thesis. First is that we plan on week 4 to gather information and to create the final thesis title. We actually execute it on the week 1 of March, and we plan also in who will be our research advisor We execute it on the week 2 of March, and we also plan on writing the thesis paper and look for RL and RLS presentation. After that, we execute the writing thesis paper and looking for presentation on the week 3 alongside with the consultation and writing thesis paper to the advisor. We plan on finalizing our chapter 2 on week 3, and we also execute it on week 3 and week 3. We gather it in members doing thesis paper and visualizing prototype of the device. We plan it on the week 4 of March, and we execute it on the week 1 of April. Next is the conceptual framework. The conceptual framework is composed of 3 parts: the input, process, and output. In input, this is the general needs in making our device. It will be used in our thesis. First is knowledge in. So knowledge in, we need basic programming, wiring, AutoCAD, visual crack detection, and selection of material. Next is the hardware and material. We use the Raspberry Pi, the camera, and the battery for our device. The software or the program that we use in making this is first is the internet, Microsoft Word, Microsoft Excel, Microsoft PowerPoint, AutoCAD, Python, TensorFlow in our program. And to make this all, we need the researcher, the programmer, and the technical advisor. In the process, it is composed of 3: the prefabrication phase, the fabrication phase, and the post-fabrication phase. In the prefabrication phase, we start on program detection, identification. Next is the data gathering. After that, we conceptualizing of camera device in detection of surface crack. After that is we purchase a material needed in making the device. After that, we will do the fabrication phase where we fabricate. After that, we test the device. If it is okay, we proceed on the post-fabrication phase where we project identification and the further development of the device. And if it is not okay, we will also proceed on the conceptualizing again the camera in detection of surface crack. Thank you, and that's all my presentation. We will go to the next presentation, which is the conceptual framework 2, the codes and standard 1 and 2, that will be presented by Mr. Nuruddin Makalolot.
Good afternoon to each and every one of you. My name is Nuruddin Makalolot, and I am here to discuss the process procedure and the codes and standards that we are going to be using in our prototype, or can be used in our prototype. So, for the process procedure, we will be having 3 steps. As what Mr. De La Rosa mentioned earlier, there will be the pre-fabrication process, the fabrication process, and the post-fabrication process. For the pre-fabrication process, we will be identifying each and every problem, gathering the data that we have collected, and knowing what type of materials we will be going to be needing for our prototype. If that succeeds, we can move to the second phase, which is the fabrication phase. For the fabrication process, we will be having 2 steps, which is understanding or knowing the structure of our prototype and evaluating the test of our prototype. Then comes the third phase, which is the post-fabrication process, which we will be having a project implementation and further development for the study. In the next slide, we have gathered all the codes and standards for visual inspection that can be used in our prototype. For example, depending on the situation, we have the boilers for the design and construction. These are the codes and standards that we are going to be using for the boilers, which is the ASME 1, ASME 2, ASME 4, 5, and 9. For the fitness and service for repairs, ASME 7 and NBIC. Those are just examples that we are going to be looking for depending on the situation. The main purpose or the main objective of our prototype is to locate or detect any surface cracks. So for that, we can use the ASME 9 plus QW194, the ASME D1,1 for the structural weld of steel, or the ZAS NZS for 1554,1 for the structural steel welding or welding of steel structures. Thank you, and that is all. For our next reporter, we have Vince Hilapo. So Mr. Vince, kindly take the spotlight.
Good day to you all. My name is Vince Hilapo from Group 6, and I'm here to discuss with you the 3D design of our device. So this case will hold all of the components of the device, like the battery, motherboard, LCD, and the external camera of our device. It has a length of 92mm, a width of 61mm, and the height of 26mm. Next slide. In our next slide, the material selections are the LCD, power bank, endoscope, silicon, lithium-ion battery, and the Raspberry Pi. The LCD is for the display of the said device so we can see the cracks in there. The power bank for extra power when needed. The silicon for button and extra grip to the phone case or the device. Raspberry Pi for the main brain of our system. And the endoscope camera to see the cracks in the surface. It also can be zoomed so we can see the defects clearer in the surface. Furthermore, the cracks inside the welded pipe can be seen because of the flexibility of the endoscope. And also the lithium battery with the 1000 milliamperes can last 4 to 6 hours of usage. For the next slide is we have the item line budget. This is the parts and the components and its price. LCD liquid crystal display cost us 1,317 pesos. The power bank is 254 pesos. The Raspberry Pi is around 6,219.75 pesos. Also, the endoscope camera costs 1,884 pesos. The battery is 1,624 pesos. And also the charger is 244.25 pesos. Also, we need a programmer that will program for us to determine the cracks on the said device or the surface of the materials. And we asked him how much it will be cost to finish this project, and he said to us that it will cost 50,000 pesos. For the fabrication of the device, we need an expert in AutoCAD and a 3D printer that costs us around 5,500 in total. For the miscellaneous fee like food, transportation, etc., we have costed around 5,000 pesos, and in total the project will cost roughly estimated at 72,043 and 22.22 pesos. And always remember that in NDT, in every material we test, millions of people are being saved. And thank you for listening to our presentation, and for any questions, kindly ask us. Thank you very much and have a great day.